In this video series, we're going to look at arithmetic sequences in series, the first lesson in Chapter 8. To start, we're going to first examine what is an arithmetic sequence. Now, arithmetic sequence is a sequence with a common difference. And what that means is you are going to be adding a number repeatedly in the sequence. And we can see that with this example down below. Is we see that we have -9, -3, 3, 9, 15. In this sequence, we are adding 6 each time before we come up with the next number. That is what our common difference is. So our common difference, we use the letter D to represent that. Now, if we were to look at it as a sequence with all variables, you start with your first number in the sequence, A1. And what you do is you're going to create the second number in the sequence by adding your common difference, so A1 plus D. And then my third number in the sequence is going to be if I add D again. So really I have A1 plus D, so that'd be 2D. Now if I add D again, A1 plus 2D plus D would be 3D. And this would just keep going on and on and on and on. The overall formula for an arithmetic sequence is a sub n equals a1 plus the quantity n minus 1 times d. So a sub n is the nth term. N, we can think of it as the term position. We can think of it like number. What number in the sequence, in the position that we were looking for. So the number of the position. A1 is the first term. And then D is your common difference. What are you adding each time in the sequence? And so that's just the general idea of a sequence. Is it's a list of numbers, they are separated by commas. And what we can do is we can also examine something a little similar called arithmetic series. And I say it's a little similar because what an arithmetic series is, it is the sum of an arithmetic sequence. And so rather than putting commas in between, we are going to be adding them. And you can see this based off the example. The only difference between the left side and the right side is we have plus signs instead of commas now. So we're trying to find a sum. And if we look at the formula for this one, S sub n represents the sum of the n terms. How many terms are we trying to add together? S is the sum of those terms. N is the same thing. It's the number, or we can think of position of the term. How many do you want to add together? A1 is still the first term, and A sub n is the nth term. What term do we want to stop at? What is the value of that term? And so we go through, you can see in this example, A1 is the first term. A sub n would be 15 on it. If we figure out what n is, n would be 1, 2, 3, 4, 5. N would be 5 for that one. So we go through, we have all this information. Now, if you want to make a note, kind of like a little warning, is if you are missing information in an arithmetic series, you want to go to the formula for a sequence. So if I'm missing something, I'm trying to find the sum for the arithmetic series, and I'm missing a value or something, I'm going to want to go to the arithmetic sequence formula to find that. So let's just try out. We'll go basic to hard as we go through. Find the next 4 terms in the arithmetic sequence. So in this case, really what I want to know is, okay, if I want to find the next four terms, I need to find what is my common difference. And to save time, I'm just going to refer to that as D from this time on. So my common difference is, how do I go from negative 12 to negative 1? Or how do I go from negative 1 to 10? In both these cases, I add 11. So my common difference is 11. So if I want to find the next four terms, here's A1, here's A2, here's A3. So the next term is going to be 10 plus 11. So that's 21. The fifth term, I'm just going to take and I'm going to add 11 to 21. So 21 plus 11. The fifth term is 32. And I can keep going. The next term, I'm going to take 32 plus 11. And I'm going to get 43. And then lastly, to find the seventh term, I'm going to take that 43 and add 11. And I'm going to get 54. And so that is really how we find the next four terms. Notice the labeling, and when it comes to this chapter, the labeling is going to be extremely important. If I want to know the next four terms, I want to know what term numbers they are as well. Find the 41st term. So what this means is a couple things. We're trying to find, and as a label, the 41st term is A sub 41, the 41st term of the arithmetic sequence. And what that tells us is n is 41. So right off the bat, I know this information. I am trying to find the a sub n term if I know n is 41. So if we look at what's given, I know a1 is 11. We know n is 41. And if I look at this case, and I see how do I go from 11 to 4 to negative 3 to negative 10, in this case, my difference is negative 7. I am subtracting 7. So if I have here, it says arithmetic sequence, so I'm going to write down my arithmetic sequence formula. A sub n equals a1 plus n minus 1 times e. Well, main idea for any formula is if you don't know what to do, plug in what you know, solve for what you don't know. I don't know a sub n. I know a1 is 11. I know my n is 41, so 41 minus 1. And my difference is negative 7. So this is actually really good for us because all we have left is this one variable. So I have 11, and see, 41 minus 1 is 40. 40 times negative 7 is a negative 280. So my a sub n is going to be negative 269 for this. And my n, we said right away, is 41. So that represents the 41st term. 41st term, a sub 41, is negative 269. So not too bad using the formula for it. Always kind of make a list of what you know, maybe even try and identify what you're trying to find, and go from there. Find the sum. So for me, that's a little interesting because now I want to find the sum. That tells me I am dealing with a series. Of the first 32 terms, so that's giving me my n. That's not bad. So what else do I know? I know a1 is negative 12. And seeing how it's listed out for me, I go from negative 12 to negative 6, from negative 6 to 0, from 0 to something else, dot, 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 and I go here to 174. So I know my common difference is I'm adding 6 each time. I know my n is 32. There's something else that's given to me. I know my first term, my second term, my third term. I also know all the way to the last term. I know my last term in the series is 174. So let's just look at the formula. I said that we'll try the series formula. S of n equals n over 2 times a1 plus a sub n. Find sums of the first and last digit, multiply by how many there are, and then divide by 2. So let's see if I know everything. I know a1, that's good. a1's negative 12. I know a sub n, that's 174, so plus 174. I know n, it's 32. Actually, I have all the information to find the sum of the first 32 numbers. It's actually order of operations now. So let's try this out. The sum is going to be 16 times, and I have negative 12 plus 174, so 162. It's 2592. 2,592. And so that is the sum, remember n is 32, of the first 32 numbers in that arithmetic series. There's our answer. Not bad, straight order of operations. We just need to figure out what we know, what's given. And you can even notice I found D, didn't really need it, but that's okay, because I might have needed it if something was missing. Find the 20th term. So what does that mean? I want to know if I were to continue this list on 4, so A1, 2, 3, 4, 5, 6, 7, dot, 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 dot. I want to know what number is in that 20th position. So find the 20th term. I'm trying to find A sub n when n is 20. So that's good. I know n is 20. I know what I'm looking for. Let's see what else I know. I know A1 is 3. And I believe if I add 7 each time, so my common difference is 7. So this is commas separating them. So I'm going to try and start first with my arithmetic sequence formula. It even tells me sequence. So always read the problem as well. There's going to be good hints on where to start with the formulas. A sub 1 plus n minus 1 times d equals your a sub n. So I want to find a sub n. I know a1 is 3. I know my n is told to be 20. That's easy to plug in. And my difference is 7. Well, if I think about order of operations, that's not bad. I'm just going to have 3 plus 19 times 7. If we have 3 plus 19 times 7, we are going to have 133 plus 3. So I'm going to get 136. Now remember, in this case, a is 20, so that is the 20th term. So if I were to continue this pattern, add 7, add 7, add 7, dot, 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 all the way to the 20th term, that's what I would get. Notice every time, I know it's only 4 problems in, but I've written down all the information that I have. I'm outlining first and then go into my formula. And it's really important for these types. When you're trying to find the equation, if we look at the equation, write an equation. So when you're trying to write an equation, we are trying to find the equation a sub n equals a1 plus n minus 1 times d. Now when you write equations, just like, and I'll just write it over here, slope-intercept form, I equals mx plus b. When you write an equation of a line, your variables are your y and x. Those you leave alone for your equation. And that's what a sub n and r. A sub n is like your y, and n is like your x. You want to leave them alone. For your final answer, you want to leave a sub n and n in the equation. You want to just have the numbers for a1 and d, and then distribute, simplify. So let's kind of see what we know. So I now know how to write an equation. Let's outline what's given to us. Well, I see the word sequence. That's helpful. So I'll write the equation of the sequence. A1 is negative 8. My difference, it looks like I'm adding 4 each time. So let's get rid of this. If I am going to write the equation, I know a sub n equals a1 plus n minus 1 times d. So I said we are going to leave a sub n alone first, and we're going to leave n alone first. So I'm just going to drop those down. Let's see what we know. We know a1 is negative 8, plus I got my parentheses, I have my minus 1, my common difference is 4. This isn't actually bad to do the formula for because I have everything given to me I need. I am just going to distribute that 4, so I have negative 8 plus 4n minus 4, and I'm going to combine like terms, 4n minus 12. And so if I see, this is my equation for the arithmetic sequence, and I could just try it out, when make a column for n, make a column for a sub n. My first term, 4 times 1 minus 12 is negative 8. Check it out, it actually works. My second term, 4 times 2 is 8, minus 12 is negative 4. It works. And I can keep going, 3, 4 times 3 minus 12 is 0, boom. So I checked a few of them, I can see it works, I am happy with my equation, so I'm going to box it and move on to the next problem. So your equation should work, and it's always good to just check a few random ones to make sure that it does. Don't just check the first one, check a few of them. This one's a little bit different though. We're not given a full arithmetic sequence. We're just given little information from it. So in order to end, I want to end with a sub n equals a1 plus n minus 1 times d. I want to write the equation for the nth term of the arithmetic sequence. So I need a1. I need my difference. Well, I have my difference. It tells me it's negative 11. That's not bad. I don't have a1. So that means I have to start by finding a1 first. I'm missing it. I know I need it in order to write that equation. It's missing. And if you're missing information when you're dealing with this, then we're going to go to our formulas to figure this out. So I know a sub n equals a1 plus n minus 1 times d. Let's see what I can figure out. So this is where I want to end. Let's just kind of fill a box. Here's what we're given so far though. We know a sub 6 equals negative 33. If a sub 6 equals negative 33, that tells us two pieces of information. First, it tells me the nth term is negative 33. It also tells me that n is 6. So when it tells me a sub 6 is negative 33, it's telling me n is 6. It's telling me the sixth term is negative 33. And we know also that our difference is negative 11. It's helpful because I now have a lot of information I can plug in. I know a sub n in this situation is negative 33. I don't know a1, but I know n is 6, and I know my difference is negative 11. So negative 33 equals a1, I'm going to get 5 times negative 11 is negative 55. So in this case, a1 is 22. So I'm not even starting with my equation. I'm using the information that was given to me to find what was missing. So I know my first term. I know my difference, so I can plug everything in. A sub n equals a1 plus n minus 1 times d. I write down the formula every time so I get used to it. I can start to memorize it. A sub n equals 22 plus n minus 1 times negative 11. So we have to distribute, so I get a sub n equals 22 minus 11n plus 11, and combine like terms. So a sub n equals negative 11n plus 33. So let's see if this works. We'll just make our table, just plug in some n's, and see what our output is. I'm just going to start with 6 because I know what it should be. So if I plug in 6, I'm going to get Negative 66 plus 33 is negative 33, so that's good. I'm also going to plug in 1 because I should know what the first term is. So I plug in 1, I get negative 11 plus 33, it is 22, so that one works. And if I want, I can plug in a couple others, but I think this is good. I think it's right, so I'm going to box it, and I'm set. So overall, the difference between 5 and 6 before we move on is 5's straightforward equation. I'm given A1 and D. 6, you're missing something. And I said at the beginning of the video that if you are missing something, you always want to go to the formula sequence. Formula for it is, even though you're trying to find a sequence, you still went to the sequence formula with what was given to you because something specific was given. A specific location was given to you, not the first term. So you got to work to find that. Let's look at number 7. Find the sum of 8 plus 12 plus 16 plus who knows how many numbers or even what those numbers are in between, all the way up to 80. So again, find the sum. So I know my end game is to use series formula. That's how I want to end. So I need n, a1, and a sub n. So let's see what I have. I know a1 is 8, so that's good. I know an is 80. My last term is 80, so that's good. So I got these two, that's good. I don't know how many there are though. So that's an unknown. That's a red flag to me. But what else is given to me is, I know it's not part of this formula. I can see now I'm going to have to find this. I also know my difference. I can see how I go from each number to each number. I add 4. So for some reason, I'm going to put down d equals 4. I think that's going to help us. Because if I want to end with this formula, S sub n equals n over 2 times a1 plus a sub n. Well, if I start plugging things in, I want to find the sum. I don't know n, but I do know my first term, and I do know my last term. I am missing n. So if I'm missing something, I need to find it. And I'm going to find it by using the sequence formula. Sequence formula says a sub n equals a1 plus, again, every time you see me write down this formula. A sub n is 80, I know that. A1 is 8, I know that. Don't know n still, but I do know my difference. It was given to me. So if I look in this case, I have all my information that I need. So I'm going to, in this case for you guys, I will distribute. So I get 4n minus 4. I'll combine like terms, and I'll get 4n plus 4. And that's going to give me 76 equals 4n. So n equals 19. So now I have everything I need to go to that formula. I can just erase that n, which is why we use pencils, and I can put 19. So then my sum is going to be 19 halves times 88. And once I do that, we are going to get our sum of the numbers, which I believe is 836. So there's your sum. And that's not bad for it. If you're missing something in your series formula, you just go to the sequence formula and solve. That's for you guys. I was going to do this one. I said I was going to distribute and combine like terms. I'll go down here and do it. And I'll write it a little bit differently. I can write it as 8. I'm going to put the 4 in front. I could also subtract the 8 first. And then I could divide by my 4 and then add 1. That's another way of solving for it, kind of isolating the parentheses first and then just add 1 for your answers. You're going to get the same idea. So again, notice pattern. If I'm missing information, where do I go? Find the first 3 terms. of the arithmetic sequence when a sub n is 29, a1 is 14, and s sub n is 1.9. So pay attention, always kind of analyze. We want to find the first three terms. So again, always figure out what you want to end with. I want to find a1, comma, because it says sequence, a2, comma, a3. I want to find the first three terms of that arithmetic sequence. Well, in order to find these first three terms, I need to be able to add a common difference each time. That's what gives me from each term to each term. So I know where I need to end. And one thing that's really nice is a1 is actually given to us. I know a1. All I need is my difference. If I know a1, to get a2, I just got to add d. And then to get a3, I just got to add d. So I know where we need to end. I need to find d. Once I find d, I got everything I need. But here's the problem. I don't have any information to get me d right now. I have a sub n, I have s sub n, I have a1. But it's giving me s sub n. I mean, if I want to find d, the only formula with d in it is this one. That's what I'm going to use to find my d value. I'm going to use this formula. So let's see. I know a sub n, that's good. I know a1, that's good. I feel a little bit better. I don't know my n. I need this. If I want to use the sequence formula, I better find n. And so that's where you kind of have to analyze what's given to you. Is for some reason this problem thought it was helpful to give you the sum. So let's go to that formula. Is the sum takes your a1, adds your an, multiplies by n, divides by 2. Well, now look what you have. S sub n is 129. I don't know n. I know a1 is 14 and a sub n is 29. So they gave me all my information, and I had to pay attention to what I knew. Now for me, I like to get rid of that divide by 2 first. You could take 43 and divide by 2. In this case, get 21.5, so 129 if you want to do it this way. 21.5 n. And then you can take your 129 and divide by your 21.5. That is one way of doing the problem, and I get n is 6. You could also just multiply by your 2 and get 258 equals 43n. And then divide by 43. Doesn't matter which one. Bottom line is you have to find n. So 29 equals 14 plus, I'm going to do 6 minus 1, so that's 5d. So 15 equals 5d. My difference is 3. Finally got there. So a1 is 14, a2 is 17, and a3 is 20. It's exactly what I wanted to find. This just took a little more thinking to get there. So I'm going to tell you that's probably the hardest one. It had to involve looking at what's given to you and wonder, why did they give me the sum? And they gave you the sum because the bottom line is you're going to be missing something. I mean, the hardest problems are you're not given all the information. I mean, I knew what I needed to find, and that's pretty simple at the beginning to think about. I know A1, so to get the next two terms, I got to add D. So I know what I needed to find. The problem is, how do I go about finding that? Well, I'm going to just look at all my different formulas and see which one I can use. I'll plug in what I know. I'll solve for what I don't know. So that's really all with these formulas. Now we can continue. I'm going to do number 9 a little bit differently than 10 and 11. Number 9, I'm going to do like we did above. All the problems above, I'm going to do it the same way. I'm going to label what's given to me, and I'm going to go to a formula, and I'm just going to find and plug in what I know and solve for what I don't know. So in this case, I need to fill in the blanks. 5 something 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 35. Well, that tells me A1 is 5. it tells me a sub n is 35. So if this is A1, this is A2, this is A3, this is A4, this is A5. So AN is 35, which is 36, so N is 6. So if I want to find these next terms in the arithmetic sequence, again, I think that means all I need to know is I need to find D. Because once I find D, it can just domino effect all the way down until it gets to 35. So let's see, do we have enough information? So it's a sequence, so here's my sequence formula. Again, look at that, writing it down every time. Let's plug in what we know. 35, A sub n. 5, A1. So far, so good. N, I do know it, it's 6. I don't know D, and that's what I'm trying to find. So I can just plug right in, 5 plus 5D. So subtract 5, and then in this case, I'm going to divide by 5. My difference is 6. So I think I can fill in the blanks. Let's see if we get it. I get 11 if I add 6. Add 6, I get 17. I get 23. I get 29. I would always just check that last one to make sure you add 6 and you get 35. You are guaranteed the right answer. Not too difficult. It's a straight plug in, zoomed in there, plug into the formula, and you want to find your difference. Now, this way is the exact same as above. All these ones where we wrote down what did we know, what was given to us, and plugged in and tried to solve. I like to think of these a little bit differently. I know where I'm starting, and I know where I'm ending. I also know that I'm adding my difference once, twice, 3 times, and then to get here, I am adding a 4th time. So I like to think about this. I am starting at 9. I am adding 1D, 2Ds, 3Ds, 4Ds. I'm adding 4Ds to that to get to negative 48. I can solve this. 4D equals subtract, I get negative 57. If I divide, I get negative 14.25. Well, let's see if that works. So if I have 9 minus 14.25, the next term is going to be negative 5.25. If I subtract 14.25 from that, I'm going to get negative 19.5. And if I subtract negative 14.25 from that, I'm going to get negative 33.75. And I hope if I subtract negative 14.25 from that, I do get negative 48. It does work. So I know it's a decimal. We are okay with that. Luckily, I saw it was quarters, and I added 4Ds, so it would end up to be an integer for us after that. So I wasn't questioning too much with this. Still, your heart races a little bit, making sure you did the math right. Let's hope this one does not have a decimal to kind of make this shortcut I call a little bit easier. You know where you're starting. I'm starting at negative 50. I'm going to add 1D, 2Ds, 3Ds, 4Ds, 5Ds, 6Ds. If I add 6Ds to that negative 50, that is going to give me 100. I can solve for D. 6D equals 150. And in this case, I believe if you have 6 quarters, you have $1.50. So in this case, 25. So I get negative 25, 0, 25, 50, 75, 100. It worked. It actually is the same formula as number 9. I am using this formula. I would say I'm just kind of looking at it logically compared to looking at the formula for it. Because I know my last term is 100. so I can kind of see the equals 100. I know my first term is negative 150, so you can see that. So I can see there's a difference. I'm using 6 here. What would I use if I use the formula? A1, A2, A3, A4, A5, A6, A7. What's 7 minus 1? 6. So I'm kind of bypassing the m minus 1 in the parentheses for it. I don't care which technique you use. If you use number 9 so it's consistent with every single problem, or if you kind of like the idea of where do you start, how many D's do you add and solve, I don't care. But this is arithmetic sequences and series. Our main idea is look at the formulas, list out what you know, figure out what you need to find. If you're missing something, go to one of the other formulas and find it.